Well, now we're going to do the review for section 5.3. So for the first question is find the exact value of each of the four remaining trigonometric functions given that sine theta equals 5 over 13, and we're on the interval 90 to 180 degrees. So draw a circle here. And we want to keep a couple things in mind, that 5, 12, 13 is a Pythagorean triple. 12, 13. Anytime one leg is 5 and the other leg of a right triangle is 12, then the length of the hypotenuse is 13. So if we see two of these values in the appropriate positions, we know the value of the third. So let's draw that now. Here we are. Let's see. So where rise is 5 and our run is 12, and it's got to be negative since it's in the second quadrant. So now sine of theta equals 5 over 13. Cosine of theta equals and tangent of theta equals, and then the cotangent of theta equals, the secant of theta equals, and I'm just going to throw in the cosecant of theta even though they didn't ask for it. And that's going to be the reciprocal of 5 over 13, which is 13 over 5. Now the cosine of theta is negative 12 over 13, and the reciprocal of negative 12 over 13 is negative 13 over 12. And the tangent of theta is negative 5 over 12, and the reciprocal of negative 5 over 12 is negative 12 over 5. And we've done it. So let's go on to question 2. So for question 2, we have to keep something in mind. First of all, the period of y equals tan theta is pi. In other words, it repeats itself every pi units. And also the tangent of negative theta equals negative tan of theta. We can move this negative out in front and write this as a positive. Okay. Also, you need to know this. If the period for some function is, let's say it's p, so f of a plus its period equals f of a, because you always land back where you started. So f of a plus, in addition to that, np, where n is an integer, will equal just f of a. So now, let's look at item A, and that says evaluate f of negative a, and this is given that f of a equals 2. Well, that's going to be negative f of a, and that equals negative 2. Now, when we look at, for B, when we look at f of a plus f of a plus pi plus f of a plus 2 pi, well, that equals by the way, isn't pi the period? And 2 pi is just an integer multiple of the period, so that's just going to equal f of a plus f of a plus f of a by what we stated here and here. So that just equals 2 plus 2 plus 2, and that becomes a 6, doesn't it? And we're done.